We're going to next talk about chemical formulas. So chemists use chemical formulas to present information about a compound composition in a really concise way. So chemical formula notation is always made up of the chemical symbol or symbols of the elements present in a compound, and then numerical subscripts, so small numbers down and to the right of the symbol they correspond to, that indicate the number of atoms of each of the elements present in a molecule of the compound. So here's the chemical formula for water. It's H2O. And so the chemical symbol in blue shows what elements are present. We have hydrogen and oxygen present in one molecule of water. And the subscripts to the right of the symbol show how many atoms of that element are in the compound. So in one molecule of water, because the smallest unit of a compound is a molecule, in one molecule of water, there's 2 hydrogen atoms and 1 oxygen atom. And when writing chemical symbols, the 1 we don't have to show. We assume if there's nothing there, that means it's a 1. So we have 2 atoms of hydrogen and 1 atom of oxygen. That means this is a triatomic molecule because it contains 3 atoms total. So we already did this. How many atoms of each element are present? We have 2 atoms of hydrogen, 1 atom of oxygen, and we have 3 atoms total in 1 molecule of water. Let's try another one. So this is the chemical formula for aspirin. So see if you can calculate how many atoms of each element are present based on the chemical formula, and then how many total atoms are in 1 molecule of aspirin. So in chemical formulas, the subscripts apply to the atom to the left. So there's 9 carbon atoms. There's 8 hydrogen atoms. And there's 4 oxygen atoms. So if you add these all up, you get 21 total atoms per 1 molecule of aspirin. Let's do another one. This is caffeine. This is one I don't think I could live without every day. So how many atoms of each element are present in 1 molecule of caffeine? And then how many total atoms are in 1 molecule of caffeine? So you'll do the same thing. There we go. The 8 applies to the carbon. 10 applies to the hydrogen, the 4 applies to the nitrogen, and the 2 applies to the oxygen. So you get there's 8 carbon atoms, 10 hydrogen atoms, 4 nitrogen atoms, and 2 oxygen atoms. And if you add those all up, you get 24 total atoms per 1 molecule of caffeine. So some chemical formulas are going to have parentheses in them. So this is the chemical formula for aluminum sulfate, and we'll learn how to name these in chapters 4 and 5. For now, we just want you to be able to calculate like the number of atoms per molecule, as well as if we had 3 molecules of something, how many total atoms we'd have, that sort of thing. So when you have parentheses, you apply the subscript outside the parentheses to every element that's inside the parentheses. So in aluminum sulfate, this 3 that's outside of the parentheses, it gets applied to the 4 on oxygen. So for oxygen, you have 3 times 4 equals 12 total oxygen atoms. And it also gets applied to the sulfur. And there's no number next to sulfur, so we assume it's 1. So we have 3 times 1 equals 3 sulfurs. So if we calculated how many atoms of each element are present, aluminum, we have 2 aluminum atoms from this 2 here. Sulfur, we have 3 sulfur atoms. We have 1 sulfur inside the parentheses, but because we have this 3 outside the parentheses, everything inside gets multiplied by 3. And then for oxygen, we have 4 oxygens inside the parentheses. So you multiply that by the 3 that's outside the parentheses to get 12 oxygens total. Then if we add this up, 12 plus 3 plus 2, 17 atoms total in 1 molecule of aluminum sulfate. So let's try this one. So this is the chemical formula for magnesium acetate. So check out this chemical formula and apply the parentheses rule like we just talked about to figure out how many atoms of each element are present and how many total atoms are in 1 molecule of a magnesium acetate. So when you have parentheses, the number outside the parentheses gets applied to everything inside the parentheses. So we're going to have for oxygen, 2 oxygen atoms times 2, because there's 2 and 2, 2 times 2, 4. For hydrogen, we have 3 hydrogens, but we need to multiply that by 2. 3 times 2 equals 6. And for carbon, same thing. We have 2 carbons, and we need to multiply that by 2 because of the 2 outside the parentheses, equals 4. So you have 1 magnesium atom. The magnesium is not inside the parentheses, so the 2 does not get applied to the magnesium. We have 2 carbon atoms times the 2 outside the parentheses equals 4 total. Do the same thing for hydrogen. We have 3 hydrogens inside the parentheses, and then we need to multiply that by 2 to get 6. And for oxygen, we have 2 oxygen atoms inside the parentheses, multiply that by the 2 that's outside the parentheses to get 4 oxygens total. So when we add these all together, 1 plus 4 plus 6 plus 4, we get 15 total atoms for every 1 molecule of magnesium acetate. So let's do another one. So how many elements and how many atoms are in each of the following chemical formulas? And then if we can, let's classify the compounds or elements as diatomic, triatomic, or tetraatomic. And we don't expect you to go above tetra, which is why I say if possible. So let's look at the first one, CO. So how many elements are present in CO and how many atoms are in the following, or in CO? So CO, carbon monoxide, has 2 elements, carbon and oxygen. It has 2 atoms within the molecule, so that's a diatomic molecule, and we classify it by the number of atoms. The next one, C with a lowercase o next to it. C with a lowercase o next to it is cobalt. So that's 1 element and 1 atom. And this is why it's so important to make sure that you do your capitalization and lowercase correctly. CO is carbon monoxide. It's a totally different substance than cobalt, the metal. So if you accidentally capitalize the O in cobalt, you'd be writing the chemical formula for carbon monoxide, not cobalt. So make sure that you punctuate and capitalize correctly when you're writing your chemical symbols. Okay, next one, O3. O3 contains just 1 element, oxygen, but there's 3 atoms of oxygen, so it's going to be a triatomic element. Okay, SO3. SO3 has 2 different elements. It has sulfur and oxygen. It has 4 total atoms. It has 3 oxygen atoms plus 1 sulfur, so that makes it a tetraatomic molecule. Okay, HCN. HCN has 3 elements, hydrogen, carbon, and nitrogen. There's 3 atoms, 1 hydrogen atom, 1 carbon atom, and 1 nitrogen atom, so it's a triatomic molecule. The one below is codeine, C18H21NO3. So there's 4 elements in codeine, right? There's carbon, hydrogen, nitrogen, and oxygen. So there's 4 elements. The total number of atoms is going to be 18 carbon atoms plus 21 hydrogen atoms plus 1 nitrogen atom plus 3 oxygen atoms. I can't do that one in my head, so I'll just grab my calculator. 18 plus 21 plus 1 plus 3. So it has 43 atoms total. And we don't expect you to be able to name, classify molecules based on the number of atoms above 4. Tetraatomic is as high as I expect you to be able to go. So we wouldn't expect you to know what a 43 atom molecule would be called. Just check our answer on this one quick. Yeah, perfect. Okay, so this is a more challenging one, another concept check. So consider the following 5 substances. We have Cl2, C2Cl6, H2CO3, H2SO4, and HCl. And something to look forward to is we're going to go through and learn how to name all of these things. So I know I mentioned in the introduction to the class that the first part of this chemistry course, kind of the first third of it roughly, is kind of introducing you to chemistry so you can learn to speak this new language. And so we're introducing how to read chemical formulas now. And as we get into chapters 4 and 5, that's when you're going to learn how to name everything, which I think is really cool. Okay, so in these 5 substances above, how many diatomic molecules are present? So how many molecules contain only 2 atoms? Diatomic means 2 atoms. So we have 2 diatomic molecules present. We have Cl2, contains 2 atoms of chlorine, and we have HCl. It contains 1 atom of hydrogen and 1 atom of chlorine equals 2 atoms total. So diatomic, di means 2 and atomic means number of atoms. So the molecules that contain 2 atoms are chlorine and HCl, which is either hydrogen chloride or hydrochloric acid. Okay, next one. How many different kinds of atoms are present? This is really how many different elements are present. And this is in all 5 of these compounds up above. So to answer this one, I tend to like to make a list. So I have chlorine, that's my first type of atom. I have carbon, chlorine, I check that one off. I have carbon, so I'll check that one off. Next I have hydrogen, check that one off. Next I have oxygen, check that one off. And last, the only one that hasn't been checked off yet is sulfur. So we have 1, 2, 3, 4, 5. So we have 5 different types of atoms present, 5 elements. Okay, next one. How many total atoms would there be in a mixture containing 4 molecules of each substance above? You might have to get your calculator out for this one. So how many total atoms would there be in a mixture containing 4 molecules of each substance? So in order to solve this type of problem, you have to figure out how many atoms are in 1 molecule of each substance. You'll want to add that together to get how many atoms would be in a mixture of 1 molecule of each of the above. And then you can multiply that by 4 because we're actually dealing with a mixture that has 4 molecules of each substance above. So the way I would go about this is count the number of atoms in each substance. So we have 2 atoms in chlorine. We have 8 atoms in C2Cl6. We have 2 plus 1 carbon, 2 hydrogens plus 1 carbon plus 3 oxygens. So we have 6 atoms in H2CO3. In H2SO4, we have 2 hydrogens plus 1 sulfur plus 4 oxygens, 7. And in HCl, we have 2 atoms. So if we add these all up, (2 plus 8 plus 6 plus 7 plus 2. So we have 25 atoms if we mixed 1 molecule of each. But the question asks, how many would we have if we mixed 4 molecules of each? So to get that last part of the answer, we need to take 25 atoms per molecule times 4 molecules equals 100. So that's the total number of atoms you would have if you mixed 4 molecules of each of the above substances together. Another way you could do it, if it makes more sense to you, is each of these numbers here, you could multiply by 4 and then add up the sum of each of those multiplied by 4 individually. Let's get rid of this. And as I'm erasing, you can look at the next one. So how many total carbon atoms are present in a mixture containing 3 molecules of each substance above? So we're just interested now in carbon atoms, and we have a mixture of 3 molecules of each of the above substances. So we can ignore chlorine because there's no carbon in there. In C2Cl6, we have 2 carbon atoms, 2C per molecule. In H2CO3, we have 1 carbon per molecule. H2SO4, there's no carbons in there, so we can ignore that one. And HCl, there's no carbons in there, so we can ignore that one. Just a note on HCl, make sure when you're reading your chemical formulas, you read this as hydrogen. And Cl together is chlorine. Depending on the font used, it can be easy to mistake Cl for carbon and iodine. So just make sure you pay close attention to the C's and the L's next to each other to make sure it's chlorine. Or in some cases, it could be C with a capital I next to it, in which case it'd be carbon and iodine. Okay, so now we figured out how many carbons we have per molecule. And we have a mixture containing 3 molecules of each of the above substances. So 2 carbons per molecule plus 1 carbon per molecule. We mix them together. That means we have 3 carbons per mix of molecules. And we have 3 molecules of each. Sorry, my pen there. Times 3 gives you 9 carbons total, because you have 3 molecules of each. So if 1 molecule of each gives you 3 carbons, then if you have 3 molecules of each, you multiply it by 3 to get 9 carbons total. Okay, so that is chapter 1. We studied and talked about chemistry as the study of matter. We talked about the physical states of matter, solid, liquid, and gas. We talked about properties of matter, chemical and physical properties, as well as the changes in matter, chemical and physical changes in matter. We then went into a lot of classifications and definitions. So we classified matter according to whether it was a pure substance or a mixture. And then pure substances can be further classified as elements or compounds. We talked a little bit about the discovery and the abundance of the elements. Then we briefly went over the names and chemical symbols of the elements. And don't forget to do the elements activity. To help you become more familiar with the 34 most common elements. We then talked about atoms and molecules and different ways to classify molecules based on the number of atoms in a molecule or based on the types of atoms in a molecule. And then we just wrapped up talking about chemical formulas, how to read a chemical formula and interpret it in terms of the number of atoms and the types of atoms. So some key concepts from chapter 1. You should be able to distinguish between physical and chemical properties and physical and chemical changes. You should be able to classify a substance as a pure substance or a mixture. You should be able to define and tell the difference between an element and a compound. You should be able to classify substances as atoms or molecules, and then the type of molecule based on the type and number of atoms. You should be able to write the name and the symbol for the most common elements. And then you should be able to use a chemical formula to derive information about the composition of a compound. Like, what are the names of the elements in the compound? How many of each element are present? How many atoms are present in the total compound? And then if you had, say, 3 molecules of a compound, how many total atoms would you have? Just like the examples we did. So something I encourage you to do at the end of each chapter to give yourself a way to summarize the chapter and to catch yourself if there's something that you think is really important, but you can't put it in your own words. That's a clue that it might be an area you want to go back and review more. So what I suggest you do is at the end of each chapter, identify the top 3 to 5 key concepts from the chapter, and then summarize each one in one sentence in your own words. And this is a really good way to, again, give yourself a quick mini review, make sure that you summarize the chapter and kind of take your last section of notes on what's the most important things in this chapter that I need to remember. And then if there's something that seems really important that you didn't quite get enough of, this is a good way to catch it and go back and review it right away before we move on to the next chapter. All right, we'll be back with chapter 2 next.